that case, I have to launch another data frame. We did the same what they call it, samples and data. I want to carry out a basic analysis with this. What I have to do, I have to launch a new one. Click on it. It will load. Okay, what I just launched has worked. So first, so what I have to do is I have to ensure that the settings should be on projected coordinate system, and I want to do the setting for projected coordinates so I can carry analysis with those with the data I have. So for what I have to do, I have to click on layers, come to properties, then I'll come to coordinates, come to projected coordinate system, click on the plus sign. I have to come to UTM, Universal Transverse Mercator, and I'll have to come to world, WGS 9084, where I've come. Then I'll come to Northern Hemisphere, click on the plus sign, and the location of that sample is on WGS 9084, UTM zone 32. This is the location of the sample, which is in my area of study. So one thing you need to understand the zone. You can get this zone from Google Earth. If you anywhere you want to work when using the coordinate system, you can actually get it. So click on apply. Perhaps I'll do a class on Google Earth on how to get all those information. Click apply, click OK. So once I'm done, I have to go back to layers again. Go to properties. Then I'll come to general and ensure that this, the projected coordinate system, the unit is in meters. So that's why I display meters, but we have to keep it in degree millisecond. But all the analysis we are going to carry out already are in meters. So that is why I say when you want to carry analysis map and do something, you have to keep it in the projected coordinate system. So we are done. So what I want to do, I can easily go to add all those information. But first, what we have to do is we have different way of doing this. We have this one here, which are the information. We have this. So I will go and load this, but I will also show you how to convert them to on this. So let me go and add. So I can right click on the layer, or I still come here to add what I want to add data. So I can come here. So I want to add data. So we have the study area. We have study area. We also have water sample. I have study area. These are the two. Let me add these two first. These are our main focus points. Now you can see some of the samples are away from this. So what we have to do, so I think what we have to do in this case, we'll try as much as possible to concentrate to ensure that the samples are actually within this area cut across the various places. So what we'll have to do is that I'll do a new study area where I will click on the drawing, then choose right angle. So what I will do, I will ensure that they are in my consign aspect. So that is okay. So that is okay. Still loading. So that is okay. Okay, so what I'll click on layer and click on convert graphics to features. Oh, then I'll click here. Come here to save. So this one will be study / area maybe I can say borehole, add it at the side. So say save, automatically delete graphics after conversion. Say yes. So immediately that's actually focused there. So we can remove this one. We can remove this one, and these are our focus. Now, one thing you need to understand, this framework, if you right click to and check the properties of this study area borehole, the framework is in projected coordinate system, but it is not the same for water sample. We have to convert it to projected coordinate system. Is loading. So let's check the data source. You can see is in UTM zone 32. So it's correct, it's actually in the right order. So I'll check for this water sample, which is the ball sample, go to properties. So you can see is in geographical coordinate system, so we have to convert it in that case. So now we've done this. So what we have to do is, since we are doing analysis, what we have to do, we have to convert this to projected coordinate system. So how do we do this? So we come to Windows, we come to search. So now to convert those, just write project and click enter. This should be on local, did not enterprise local. So this one is for vector data. You know what you are doing with vector data. You also have for raster data, these two. So don't use this. This will override your data. So click on this, double click on it. So you add that layer, so it's the water sample. It's loading. So that's, as you can see, it's telling you that this data frame is in geographical coordinate system. So for me to convert, so we come here, right click on this, come to projected, click on the plus coordinate system, click on the plus sign, come to UTM, then you come to WGS 1984. So you come to Northern Hemisphere, go to WGS 1984, UTM zone 32. So this is it. So you click apply to enter, then you click OK. So it's loading. Okay, it has actually loaded. So you can see we successfully convert this. So for me to so this is this, so you can off this. So you can see it's still there. So what I want to do, I want to export it to our folder so that anytime I want to save it in our known folder, which is water. So this the other one is geographical coordinate. So we can see borehole sample underscore sample. So I can put project coordinate system so that I don't forget. So yes. So because why I say yes, so that I can remove this one, and I know that I have it already in my working folder. In that case, so we have this information. So at this case, we can remove this. Now, like I said, these are the information. I want to do analysis map on this thing. So what we have to do is that now we now know that this is our known area of our working interest where I want to do some analysis. So meanwhile, let me just do analysis before doing other further work. So first, what I want to do is to do a simple analysis with this. Just for me to do, I right click on the borehole, come to properties. Then you can now see that this sample is in projected coordinate system. It's no longer in geographical coordinate system, projected coordinate system, so it's in meters. So I want to do simple analysis, so click on symbology. Then we can come to categories. Want to do some quantitative analysis. So we can simple add, maybe I want to do quantitative analysis for P. Let me take like iron. So I want to do some quantitative analysis for iron. So on the map, so you can see the quantitative analysis where they have different color notation. This analysis, and this color tells you, oh, this sample that range from this to this represent this. So where you carry out analysis, you can carry out this type of analysis in your map. So what I want to also do, there are many analysis. I just want to show you how to visualize some of this information. You can go with symbols. So let us say that we have something of this nature that I want to use. So like this is okay. 5 class. So I'll just do it. Also do it for iron. You can do it for any other one. Just do it for iron. So just click this. So you can see those who have big, they're talking about the iron is high from this to this. So now we can still use different system of doing it. Okay, let's also try for proportion. Where maybe you're still using iron, for example, and the unit is in meters already. So some of them not sure. Let us, this one is not sure. No, not this one. Let me do the right thing. And not this. Let me just use. Okay, this is a water quality index that has been calculated in this data. So which is also a valid way of doing it. So just want to check some things. Okay. No need. Let me just work on our iron that we use as a case study. Trying to do some play around with it. Let me just this add all. No, it will be too much. Okay. Sometimes I just check. Okay. No, I'm just trying to check. So let us use, for example, let us use something that will represent. Okay, let us say that we want to plot bar charts for iron in various locations. So I click that and I'll add this. So let me just show you what I mean. This is what will now show various bar chart. But pie charts, there are so many information when you want to do pie charts. But notwithstanding, I want to do like iron, and maybe I'll just do iron and this. Maybe like 3. Let me use chlorine. Maybe we can change the color. Maybe yellow. They will give iron. I'll give iron red. Can give iron red. So we can also give some blue. Just this case, I'm still apply. So what will happen now? This is what will now come out. Just want to carry analysis on each of those various locations. You can see how you could play with it. Just to play with it on this map. So notwithstanding, you can still do. We can still go back and apply for bar charts. So for example, I want to do bar charts for like a group of sample like 3. Let me say iron. What to do for potassium, maybe. But also we're also doing for this. Let me also say this. I think they are okay. Let me see, iron is red. It's red. Let me see, potassium is maybe yellow. Sodium is green. And let me say this one is also like this, okay? So so you can apply. So you can see beautiful analysis that we've been able to do in this case. So obviously you can also do label. So you can see the various borehole we show on the label. So now, like what are those? So you can carry out a lot of analysis, graphical analysis on it. You can do so many things with just this format of operation. You can do so many things just to tell what this is. So like I said, there are so many things if you want to do, you can use this to do. You can also see do stacking pattern. You can see do some multi-criteria work, can do so many works on it. Like I just showed you this one earlier, talking about variables on size. I think I've showed you some of them. So like I said, you can do so many things with it. Stacking pattern for the same purpose too. You can do a stacking graph. So you can see the stacking tools. Can play with it. So you can do so many things with just these features. You can do so many things. So like I said, it depends on what you have, what you have to offer. You can see like we've done this. So this is another area that you can run your analysis, play with it for each of them. You can do it for each of the samples, one by one, different map. This for iron, this for this for that, just to represent this data for anybody can understand what you're doing, can play alongside with it, around with it. So another one I will just quickly show you is not this. Let me go back to symbology. Let me return it back to its normal place. So at the point my sample this will show. So another one that I can quickly show you guys will not take time. We'll just run some spatial distribution for me, one or two, just to see how we can talk about. We can differentiate it based on spatial distribution. So in that case, you click on Add Toolbox. Okay, so you can now see that I've actually on my Add Toolbox. So I just want to just run just maybe two, and I'll go to another phase of what I want to do. So what I have to do is want to run analysis. Okay. So we just come to spatial analysis tools. Then come to interpolation. So we'll be using IDW, inverse distance width. So we're using this. Just a simple analysis I just want to show you as part of analysis map that I promised to do. So first you have to do add the borehole sample. Then this Z value you have to put, maybe let us do for iron. The number of samples we are working with about 30, about 50. So let me just change that to 50. Then to ensure that these areas in the map are also indicated, so come to environment, come to processing extend, come to default and put this study area. Then you also do the same thing, come to raster analysis, then they click on mask, click on also study area, click OK, click OK. Okay, let us save, keep it where we'll save it. Let us save this in our normal folder where we are working. Come to desktop, come to training, and come to there. So you can save it. Let us say ionf.tif type format. So click save and click OK. So it will run the analysis out. Okay. So this is a spatial distribution map for ion. So you can see that we can maybe do some little analysis for proper clarification. So right click on it. Right click on it. Come to symbology and change. Can keep it the class to be like 5 just for normal analysis, and we can still come here and just to check. Okay, can still come, you can click on this side here, come to format label, so you can keep this thing at 2 decimal place, like 2 decimal place, and we can change the color from, can change the color like this for proper visualization. So we can now see that the standard from WHO, we all know that the standard, the permissible limit for iron in water is 0.3. So we can now see those that are above 0.3 will definitely have different sample color. Those that are less than this will have different sample color. So we can now see something of this nature on this map. So we can now see, we can see how the red one that they're actually in between permissible limits. This blue and this color, they're actually above the permissible limit. So, but we can still use another way. There's a way, different way of representing it. So we can divide this to like 3 class, maybe high, low, and so we can do something. Let us just go to properties. I just want to show you some simple analysis that you can carry out for this. Let me say we are classifying this thing in 3 class. So very low, low, let me say very low, low, and high. Let us say 3 class. So if I'm going to do class, I'll just change that to 3. And I will say that, let me say 0.1, yes. No, let me say doing to 4 class. Let me say I'm doing 4 class. 4 class should be good. Let me say I'm doing 4 class, like 4. I think 4 is good. 4 class. So let me say here is 0.1, very low, 0.2, low, say 0.3. I say, let me say normal or medium. Then anything above 0.3 is high, which is high is not accepted. So we have something of this nature. So I've been able to do something, so you can see it. Very, very nice outcome. So what I'm trying to say with this now, I can just do a simple, this analysis for iron, and I can do something. Let me just reduce the font, the size of this, and let me can come here and I can do a renaming. I can rename it. I can come here. I can, if I don't want to rename, I can still keep it at this. I say very low, I'll say low. I can set to come here and say medium, medium, or I can even write here just for basic understanding, WHO limit. I can say high. I can say above WHO limit. Just for someone to understand what we are trying to say when the analysis, just so we can do this. This is just a normal visual. I just use my own analogy to just trying to explain why is this information like this, just for anybody to understand. So we can now see that anybody that sees, so we can, with this now, it will help you to understand. So I like changing dark. Anything dark is not accepted. So let me change it like blue. Then I can change that to like something more nice, maybe a nice color. Let me, I can put green, nature. So we have something of this nature. Now see that this is a map or iron map of the place of Yenegua, showing the spatial distribution of house, the concentration of iron around the area, and the ones that are above limits. So with this now, one we actually know that, oh, these failed samples are not within this area, are not good. They are actually above the limit, so that they can carry out treatments on the various boreholes in that area. So this is just simple something I just wanted to show you guys. So we can, what I did in the previous video, just to do a template, let me just do it. Let me change this to landscape. Like I said, this is just a simple analysis map trying to run. I just show you simple how you could play around it. So just trying to show you how you could play around it. So it's quite easy. It's easy. That's easy. So it's easy to run this. So you can see that it's easy. So what we want to do, we need to put the grid, we need to put the legend and the rest of them, what we did previously. So you can right click on it, go to property, we come to grid, come new, next, click label only, next, I click apply. So it will simply come out. So what we have to do, we can just run a little visualization, just play around with it. It's loading, let's just wait a little. So what we have to do is task purpose. So like I said, you can increase that to 12, bold it, come look at the left and right, this both sides, so right, left of it, click apply, click this. So okay, so okay, I'll drag this in a little to a sample. So this is nice. I think it's still okay, just that this right up and much. It can still be adjusted. Okay, I'll just leave it like this. So let us add other features that need to be put. So let us come to insert, can put the legend. Okay, let me just keep it like this way, then we can do others later. Oh, okay, load. So your thickness, okay. Like I said, this is analysis map, so you expect different kind of. Let me just do small tricks to insert inclusion to 14. Even have space. It's too much. Let me go back. And increase it to 12. 12 is okay. Okay. So we have this already. So what I will just do is I'll just clean up this. Okay. And what I will do is I'll write iron. Also put so that is the concentration of iron. So you can see, so this is okay. So this one is, you can see, study area. You can see ground. Sorry. Water. So you can see groundwater on it too. This is just a simple map. So we can also see label, bring a label, like bold them by like you click on it. Which is so click on select all bolds. And just click OK. Okay, yeah, good to go. So this is okay. Let us add other many information. But I will change this color size. Maybe I can change it to black and just reduce the label to black. Okay. So what I will do is also add the remaining information, such as this. I can decide to use this time. And put it here. So I can decide to come and put this. So I've actually inside the scale. So what is left is just few information. I think I removed this before. I put it back. Put it back. Okay. So we have this, just a few information we can put. We can put the coordinate system just to show the coordinate system that we use. This is that is okay. Okay, we'll set it properly. Okay. This information is okay. This is just an analysis. So you can see that with this, I think we can decide to put the data frame as usual. Let's put it on click count properties, change out no color, set to black, change out to 2. So you can export this as usual by click on file, count export. This is what we do for spatial dispersion map, trying to use WHO standards, play alongside. You can, it depends on what you want to do. This is from Iron. So consider to use this. This is just so, like I said, this is another way of you can run analysis. Depends on how you want to run. We can still do something again. If you off this, like the previous one I did, you can still come back here, come to symbology and play with what we've done before. We can still, I'm trying to check which of them will be suitable. Still use the iron. No, use this. Let me look at whether we can use select analysis. Okay, let us use the range quantitative analysis aspect of it. So you can decide to use something of this nature. So nice. We're using this coming. We're trying to check how every information is. So you can see format the value to be in 2 decimal place. I'll put it into decimal place for basic output. So you can see, but this case, this is just talking about how color could differentiate the map. So, but you can see do other way of doing it. Can use the system. Okay, the class of 5. Okay, that is okay. So you can see the whole information. I'm trying to talk about those who are high, who are low. So you can see, so you can do a map of this nature. This is for iron. So you can put your label. So you can for maybe you can increase the font size of the label just to make it bold. So you can do these are all analysis that you can play around with when you want to carry analysis to interpret. These are some of the analysis. You can decide to bold and increase the font size. We can put to 12, like say okay. So you can see how they are. This is for iron. So the same thing that has been done, and you can decide to copy this and come here and paste inside the iron. So this one too is still an analysis map trying to represent iron, so you can export it. So it depends on what you want and how you want to do. So see iron. So you can put this and say 2. Which one? Analysis. So let me also use something else. You can right click. Then let me use. So you can come back. We have one of proportion. So let us use charts. So for example, let us use bar chart. We want to group, like I said, we want to group iron chart. I want to group for this like a chart like that. That take like 3 group charts. Let's say iron is, can give iron red. It's okay. Can give potassium. That will give me yellow. Let me give chlorine. Maybe this blue color. Okay. We're trying to check what we've done. So end of the day, you can see what we've done so far. So this is it too. So it depends on what you want to, like I said, it depends on what you want to do. Export it, run analysis. You can still go back to do the same thing for pie chart. You can see the same thing for this. And let's do this. So you can see this also for pie charts. So you can export it and get your results and rest of the rest on. So you can see, you can do a different analysis with it. So this is some of the basic things you can do using these tools on a map. So you can see, you can run chart on it. So thank you.